Hey guys, welcome to my channel. This is a real data science channel. In this channel, I create videos on fundamentals of data science, understanding data science from a more generalistic approach and a more fundamental approach rather than specializing on any tool. Although, occasionally we can also do that if there is a demand. So, as I told you in this video, I will be automating the need to learn SQL, right? So, you don't need to learn SQL from now. There's a framework called RAG framework that we will be using in this video to create SQL queries from natural language, right? So basically you will be writing English and then the OpenAI's API which is using an LLM model that will be converting your queries into SQL query, right? And then we can also try that query on the database and see how it works, how it's working. So what's the need of this? What will be the implication of this? How these kind of things will change time? What will be the problem with this thing, and does it require any high-tech knowledge of LLMs, and who all can use it? We'll all discuss everything. So watch the video till the end, and yeah, let's dive into the video. So before diving into the code, let's just understand a bit of outline, okay, what we are actually going to do here and how this is working. And this is the part 1 of this video. In part 2 of this video, I'll explain you a complete RAG framework of how a RAG framework works. This is based on RAG framework. There are other applications of RAG framework as well. So we will be doing all that thing in the part 2 of the video. But yeah, let's just dive into how we are building that outline. So what we are going to do here is that we'll take a simple data frame, right? Simple Excel file. We'll convert into a Pandas data frame. And then once we have converted that into a Pandas data frame, we'll store that into a temporary DB, right? We'll make a temporary database in the Jupyter Notebook environment. We can usually do that using a SQL Alchemy library. So we'll use a temporary SQL Alchemy library to create a temporary database. And once we are done with that, then what we'll do, we'll actually do some testing on the database, whether it's working or not. So once the testing is done, then actually we will use this data frame to create a structure of this data frame, right? Structure or definition of this data frame. This definition of a data frame will act as a context for our RAG model. So will act as a context for our LLM model for now, we can say, okay. Now this definition plus a prompt. Prompt is nothing, just a query that we gives to LLM model. So this structure, that is this definition plus a prompt, we will pass both of these things into a LLM model, large language model. And that model, what that model will actually do, it will read this definition ki hey, there's a table that looks something like this. These are the columns, which columns had which value, those kind of things. And then it will make a SQL query for us based on the prompt. So for example, if my prompt is find the total sales for me, right? So it will try to find the column that is most related to sales, and then it will sum those columns, right? It will prepare you a query to sum those columns, right? So then it will prepare your query, and along with this we'll also give it some starting point. Starting point is something like how do you want your query to be structured, right? That thing is also important in LLM. So as we'll dive more into LLM field, we'll understand each things properly, that okay, what is prompt engineering, how do we structure a proper LLM model, how do we connect to an LLM model, what is an LLM model. We will be covering all of those things in a generative AI series. But as of now, it's important for you to understand what we are doing here. So what we are doing here is we are just making a definition of a table based on SQL Alchemy library that will help us make a definition of a table and store a temporary database. And then to make a definition, we can also always use this column structure in Pandas to just pass as information to that SQL Alchemy library that helps us prepare a definition of a table. And that table plus a prompt plus a starting point, okay, how do you want your response to look like, we'll pass all those things to a LLM model, and then we'll see the results of it, okay, what happens. So this is a general outline what we are trying to do here. The things that I'm using here is a bit idea of NLP, because if you don't know NLP, you will never get an idea of how LLM works. LLM models, how do we connect to OpenAI API, right? And along with that, you can also learn about a bit of SQL Alchemy library, okay. So if we'll go to a demo of it, right, let's go to the code part of it. That is an interesting part, okay. If we'll go to a code part of it, you will see that the first step that I have done is I have imported some necessary library that will be required. So we will be requiring OS to store our environment keys, we will be requiring Pandas, we will be requiring OpenAI. How do we connect to OpenAI APIs? I'll make a different video on that, because that is a bit different segment, right? And it's not a big thing, but I think your video will be helpful for students, so I know I'll make a video on that. So I'll get this data. I've got this data from Kaggle. I've downloaded this data, so I'm just reading that data into a data frame, preparing a head of that data. If you see the head of the data, I have order number, order quantity, price each, order line number, sales, and a lot of other columns. One thing that I want you to notice here is that all of these columns are meaningful. Sometimes it can happen that your columns are not meaningful, and in that case this particular method that we are doing might need some advancement, because in current scenario it might break, because what you are giving here, it's a definition of your table. You are telling that LLM model ki, hey, these are all my codes, these are all my columns, and if that column name does not make sense, then it cannot connect your prompt to that column names. For example, if my column names is column A, column B, column C, and if I'm giving a prompt like find the total sales for me, right? So it cannot connect the dots there, so it will not be able to answer you properly. But if you name them, name your column properly, it will be good. Next thing, if you just write simple queries, you have sales, just there a simple Pandas query here. Then now let's do one thing. I have imported SQL Alchemy, right? And in this library there are some tools that can help us create some temporary data frame and create some SQL engine where you can run queries, right? So what we'll be doing here, we will be storing our database into a temporary database, our data frame into a temporary database, and then we will run some test query on it, whether the database is working or not properly. So I created a temporary database. So there is a library, there's a module called create engine inside the SQL Alchemy library. You can import that, and once you'll import that, I can create an engine on that temporary DB, and then what I can do is that I can pass my data to that particular temporary DB using this, right? So connect with temporary DB, pass this table as sales df to SQL. Once I run this, you will see that my data has been stored there, right? And it is being stored like this: create table sales, all of those columns are there, table types are there, like it's just reading the column types from the data frame type, right? And all the data that it has stored there as a SQL table. Now I can connect to that SQL DB using tempdb.connect_sql, and then you can run a simple SQL statement there. I have run a simple SQL statement called select order number sales from sales by just any simple SQL query I can run there. So this will basically give me the order number and sales, and it will order by sales amount in the descending order, and I'll get the limit one, that is I'll get the top order. Okay, so I run this, I get my value in results. If I just print results on all, these are my values that I got from this SQL query. So basically what we have done till now, we have made a temporary database, we have connected that temporary database and run some SQL query, so that thing is working fine. Now what we will be doing here is we will be connecting to a LLM model. So we cannot build a LLM model ourselves as of now. So what we will be doing, we will be connecting to OpenAI's LLM model that allows us to do chat completions, right? Chat and completions. So we will connecting to that API here. Okay, so for that you will need a API key. This is my API key, right? So by the time this video get released, I'll deactivate this API key obviously, so you cannot use it, but you can just go to OpenAI, create your own API key. I will make a separate video on that to how to do those things, but this is how you get an API key and store it into your OS environment. So store it basically in your environment, and then you can fetch it out from there, so you don't have to write this again and again here, right? Now next thing what we'll be doing is we will be informing our GPT model about our table, and to do that what we can pass there is a context of a data frame. See, we can pass our whole data to a LLM model, but that is a little unsafe. You cannot pass a database to an LLM model, because you don't want to make your data public out there, right? There's some rules regarding data privacy and all that, so you cannot do that. I mean, you can do that, but ethically you should not do that, right? So what we will be doing, we will be creating a definition of our table. Definition of our table would be something like a structure of a table, giving a context of a table ki, hey, this is my table, it has these many columns, and this is what I expect you to do, is will go in a prompt. Okay, so when I create a table, right, when I create a table, I get something, create table definitions. So I create my prompt something like this. So whenever you make a prompt, you write it in a triple quotes. So SQLite SQL table with its properties. So I'm giving a context ki, hey buddy, I'm giving you some table instruction, and these are the instruction for that table, right? So this is a sales table, and I'm passing that as a format, right? And if you'll see in format, I've passed df dot columns, and I've done a comma and join star. So what join strx, basically I'm converting that column names into string and separating them by a column, so that I have to pass it in a structured format. If you are getting confused here, just write your column name directly, just to see how things are working. Ideally, if you want to optimize your code, write it in a more professional way. You should write it like this, where you don't do repetitive tasks, instead of use a join function there. Okay, and I return a prompt here. So if I see the output of this table here, output of this function here, so this is what is being passed as a query to my LLM model, is, hey, this is my sales table, it has these columns, okay, and it's an SQL table, and these are its properties, right? This is what I am given to my LLM model. I'm going to give my LLM model, right? So I prepared it as of now. Now next thing would be prepare your prompt. So for that also, I just took an input from the user, which is NLP text. What is a prompt? So let's say I want total sales by country. Okay, I have a country column, I have a sales column, so I want a total sales by country, right? So it will group by country. Okay, and if I run this NLP text total sales by country. Now what we'll do now is we'll combine our table definition and we'll combine our prompt, right? So we'll make a combination of both of them, and then we'll pass this thing to our LLM model. Okay, so to combine it, we pass our data frame here and we pass our query prompt here. Data frame pass into create table definition. It will make your table definition, same thing that we will printing above, the table structure, what all tables we have. And then you have query initial string, so a query to answer, and you have query prompt, and return definition plus input string. So once I run this function, you will see that I have SQLite table, the fun thing that we were getting in create table definition, and I have a query to answer total sales. So I've also given this is a query. That thing also you have to differentiate. See, when you're dealing with an LLM model, although it knows a lot of things, it can do a lot of things for you, but you have to pass a good prompt there. You have to give a context of information there, and this is how we give a good context of information. This is a good field actually, prompt engineering. If anybody of you wants to opt that field, I'll surely recommend it. It's more about how do you talk with LLM models, right? How do you generate more efficient queries to understand models, and to have a good understanding of that, you have to have a good understanding of LLM model as well. Then only you can make good queries, right? Next thing, once this prompt is prepared, now I have something to pass to my LLM model. Now I have something to talk to my LLM model. So now let's talk to our LLM model. So OpenAI call, and what I'm doing here is I am importing OpenAI module from OpenAI library. If you don't have this, you will just have to do a pip install OpenAI. It will install these things for you, and then I'll create a client, right? And client, I'll just call this, initiate this OpenAI module by passing a API key. I think I've done it above as well. I think I forgot it to remove it from here, but yeah. Then I am creating a response. So I'll use client.chat.completion. So this chat.completion makes it understand that there's a module of chat.completion that allows you, okay, this API that is hitting there which actually complete my sentence, do a chat with me or do a complete my sentence. There are other APIs, well, there's embedding API, there's a vision API. Embedding API is when you pass text there, it will create embeddings for you. And for vision API, if you write something, it will prepare image for you, right? So they have different models for each of the APIs. Here we want to use chat completion API and use the model accordingly. So we are using GPT 3.5 turbo model, temperature 0, maximum tokens 150, and top P1, frequency, penalty, just a simple standard parameters, not any specialized parameter. And now At the end I am passing a semicolon. Okay, give me a semicolon head, and then message. Okay, the message that I am passing is content as combined prompts df nlp text, the function that I have created above. It will be the same response. So this will be nothing but my this response, right? Once I run this, let's see what we get. We got some response, but the response will not be in the proper readable format, right? So we got some response, and if you will see, we have got our query as well. Okay, where is our query? Here, some sales, right? We have got something here. Let's see. Okay, yeah, so we have got something here, but we need to extract it. So what we'll do, we'll add a select also there, and then we query. So if you'll see query, it's like sum of sales and all. So we have to add the select additionally because the model is not giving us. So in this function nothing, I just cleaning that thing. And this is your LLM type of content, right? Chat completion type of content. So to fetch things from here, you'll have to go into choices first. You see choices here, and that choices, your first element would be your main content. In that you will be checking messages, and in that you will be checking content. And that content, if a query starts with like blank, like if select is not there, I'll add select additionally, right? So finally, if I'll run this, this is what I got from my code. So yeah, it basically converted my natural language. Hey, give me the total sales by country. It converted that into SQL query, and now I will run this SQL query on my temporary database, and it will run. Okay, now if I pass this query into my temporary database, let's see, it ran, and let's see what results it gave. It gave me a countrywide search. So basically here I have eliminated the need to learn SQL. And not just I, there are many research papers on these things. There are many ideas on this RAG model. This is one application of RAG model, guys. I will encourage all of you to explore more on RAG models, explore more on generative AI as a whole field, and what things you can contribute there, how you can optimize things. Now I want to talk 2 points here. Point number 1, does this actually eliminates the need of SQL? Okay, see, till now I'm using a basic model. GPT 3.5 is a basic model, and I'm using a simple data frame, and I'm passing a simple query like find me a group by statement. I'm asking it to make. That's comparatively an easy SQL statement, right? If I would ask it 2 different type of joins, I create 3 different type of join, create more optimized SQL query, that would actually be the real testing of these kind of models, these kind of frameworks. So that is the next thing, more complex queries, right? Complex queries, these are kind of a limitations of this, right? So with this basic model that you're using, the GPT 3.5 model, it will not able to handle that complex queries. Second thing, you are passing your data there, right? I am passing my data to OpenAI model. Now this is obviously an open data, so I can pass this data to OpenAI model, but you are making your data public there. Although I am saving something, that I am not passing actual data there, I am just passing the schema there, but still you are passing some of your information to the outside world, and that it's a problem. For example, in some cases, for banking applications or trading applications, they tend to hide the features that they are using for their algorithms, right? Business wise, they don't want to show, hey, we don't want to show what all things we use in our models, right? So what all data we use for our insights. So you're not showing actual data, but you're getting an idea of data. Hey, they're counting sales as well, they're counting countries as well, those kind of things. So one way or the other, you are passing some definition outside, so that is also an issue. So yeah, there are some issues with this kind of models, but the thing is, again, if you don't trust Microsoft with the data, then who can you trust? I'm using an OpenAI model here. You're already storing your data somewhere, and it's again, if used properly, they will give you a customized model. They will save your data in Azure cloud and somewhere. So yeah, this has a lot of business applications. And the other thing that I want to discuss, that does it actually will take anyone's job? So yeah, if you're writing simple queries, these things are also obviously present there in Microsoft Copilot. For just a raw applications of it, where I'm again creating awareness, okay, that how the world is evolving, and if you're running behind, then you'll lack something. So it's time to upskill, and it's best time to upskill actually, right? Because you have AI to help you, and your goal is also is to learn AI, right? So that completes a cycle, and AI is a evolving field. And yeah, that's all about this video. My name is Shumankar. This is a real data science channel. I'm currently working as a machine learning engineer. I also create content on LinkedIn. You can check my LinkedIn post, you can check my Instagram account, you can follow me on Instagram or LinkedIn, and please do subscribe to the channel. Thank you.